me record here. Okay, that's the last slide we left off with right here. It was dividing. We couldn't do synthetic division because this guy was not what? Not linear. Yeah, linear just means it's kind of like x plus a value or x minus a value. That's the only time synthetic division would work because we need to solve it and then we go from there. This one, I know it's been a weekend, so get your math juices flowing here, just a bit here. Okay, there you go. Say again?
No video today?
No video, sorry, just gonna keep on going just to make sure we can finish up here. So then let's do this here. Let's back up a little bit. Any homework questions on anything up to 33 on 2.3? Let's do that. If you guys can take a look at your work. Did you guys get stuck on anything there? And then we'll move on with the rest of it. Some people already tried the rest of the homework. That's cool too. And if not, we'll go on. Just want to make sure that we do have honesty question. How many did already start the homework?
Wow.
Okay.
I don't have a question about up to 33. I had a question because I got through most of it. I didn't look up a Khan Academy video, but can we go over number 53?
53, absolutely.
Because that one was confused on.
Let's do that. How about I'm going to do something similar to that, like a 52 that's similar, and then we'll do it as we do the rest of the questions. So, okay. So let's jam. Okay, so the rest of the homework, we learned how to do long division. We learned how to do synthetic division. And so now we begin with just the exercises with them here. So exercise number 8, it says write the function. That should be in the form of k times q of x plus r. So all the different components here. So given k, I got to give you k for that here. So I'm not sure if we'll do another one here, but to start off with, this x cubed minus 5x squared minus 11x plus 8. And then I say that the k value is -2. So notice it's just a single value. So a few things we should notice about this is notice on top, we're gonna rewrite it as a multiplier. Let's go back to long division from pre-algebra. So if I want to divide 5 into 43, we say to ourselves, oh, that's 8, right? 8 times 5 is 40. We got a remainder of 3. Everybody good there? So the question is this: can I rewrite 43 again in terms of multiplication and what things multiply to it? Absolutely. It's going to be 5 times 8, true, plus 3 at the end. That makes 43. Essentially, we're doing the exact same thing, just with polynomials right here. So let's see if this would make sense here. If this is our divisor, notice it's x minus k. If I just say, okay, what am I dividing by? So let me do it like this here. I would say I'm dividing by x minus a -2, which is technically x plus 2. We're good?
What does the Q represent?
Q is your quotient. It's it's what's on top. This guy's your Q value, which you got after you divided. And the x minus k is your divisor, what you're dividing by.
Oh.
And then the 3 is your remainder. So there's your kind of all the different parts in terms of pre-algebra. Cool. Can I use synthetic division? Yes or no? That was a slow yes. Like
Synthetic.
I mean, it doesn't look linear.
right here. Does this guy look linear?
Oh, yeah.
Yeah, we're dividing by x plus 2. Absolutely. We can use long division here. And so, dun, 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 going back over here, we actually use the k value itself. Oh, sorry, that's a different way to do it. That's the way the notation goes, right? Yeah, there's kind of 3 different ways to do the notation for synthetic division. This is the way the book does it. Okay, so yes, we can. In fact, this guy right here is your divisor out there. Good there? So let's plug in some values here. What number should we put down?
1, -5, -11.
And an 8. And then we usually make this guy to be a special one because that's our remainder. Whatever remainder there is. So all yours, give you guys 30 seconds. Can you guys do it yourself? Go. Cool, and should be all done. 1, okay, it's a Monday, right? So we got to think about, so we add down and we multiply back up. Is that right? So multiply. So -2 times 1 is -2. Add down. Add down again. It's a small little itsy bitsy multiplication mistake usually throws people off. Or addition mistake. Thank you. Awesome, thank you. And voila, I give myself a 2. Okay, let me erase all the. Boom. Okay, so now my leftovers. Here's my leftovers. My leftovers are x, let's see, this is my constant term, this is my x term, this is my x squared term, true? Sweet, okay, so I got x squared minus 7x plus 3. Okay, how do we write this? So my function now is x plus 2 from over here. This is what I was dividing by. My quotient, what I ended up with was x squared minus 7x plus 3. And my remainder is a plus 2. Again, just going back over here. We are just rewriting our function in terms of just that one factor being factored out. Good. Okay, you guys talk to me, does that make sense there? Maybe we've kind of, let me erase all this that we just did over here. We pretty much just did this right here of pre-algebra right there. Right, we divided the 43 by 5 and we said, look, 43 is the same thing as really 5 times 8 plus 3 more. Okay. You guys talk to me, do we need to do another one of that? Or are we okay? Yeah, Abby.
The top equation, the R is the x minus a is the divisor, the qx is.
Yeah, q is a function, so it's q of x.
Oh.
And it's the function that's left over. It's the quotient. Technically, we just say quotient function.
Got it.
Good. Yep, absolutely. Okay. Let's see. Thumbs up if we're okay. Thumbs down if you need to do it another one just like it. Cool. Okay. Got thumbs up for the most part. Okay. Let's jam with the next one. So. Trivia question from last week here. How do you know whether something can factor into something else? And the problem here. How do you know if this x plus 2 could have been a factor of this guy. We kind of hinted at it on Friday. No problem. How do you know whether 5 will go into 40? Notice right here, 5 times 8 is 40. What happens here is that we say, oh, look at this, 40 is just 5 times 8, and what's missing now? I think the remainder is missing, right? There's no remainder here. So that means actually just 5 times 8 is 40, or we can say that 5 is a factor of 40, 8 is a factor of 40. We're good? So when we do something like this, we say, look, guys, can you factor this for me? What's this in factored form?
Squared minus 6 plus x minus 6 plus.
No, this is the 3 and
36,
4. It would be x plus 3.
X plus 3.
And then multiply by x minus 4.
Okay, are we agreed there? Anybody? Everybody? Notice what's missing. There's no remainder at the end, right? Not like we had here. So if there was no remainder, if this was gone, then we would say x plus 2 is a factor of this whole thing. Are we good? Because now we just no remainder. It just multiplied or divided directly into it. Okay. So let's do this here. Example number 9 is talking about that now. So it says, we can actually use, it actually even tells us, use synthetic division to show that x is a solution to the, we're going to do third degree equations here, third degree polynomial. Then find real solutions. So this one's going to be a little bit of a big step here.
Is that supposed to be an X and a different line?
Thank you. Okay, use synthetic division to show that x is a solution to the third degree equation. And find all the remaining solutions here. Let's do one. This one probably will have to do 2 here. So A. Let's go with this. Here's my third degree polynomial equation right here. Missing x squared, that's okay. I need to show this here. I need to show that -4 is a solution to this equation. So we can do it one of 2 ways. So to show that x equals -4 is an answer to this. One way we do it is we just say, look, how about if I plug in? I'm going to plug in -4 into this. Is that the way we do it in algebra? You say if that's a solution, then this has to be true. All right, anybody -4 times -4 times -4? -64, thank you. -28 times -4. Positive 111, positive 1.
The negative at 28.
I think negative, positive 112, is that right?
Yes, 112.
112, okay. No problem, okay. And we're gonna just check in here, and I think that's true, huh? What I like to do, I add up all my positive, add up all my negatives. That's 10, that's 12, and 10, 12, that will make it. All right, we've proved it. X equals -4 is a solution. That's awesome. Okay, now the question is, it tells us to find all the remaining ones as well. Oh boy. Okay, I think we're going to do what we just learned in example 8. If this is a solution, I go next and I say to myself, I can use synthetic division to divide this out. What are my numbers?
One, 0, -28, and then -48.
Okay, and what do I expect to be the remainder?
Whatever number.
No problem. I expect the remainder to be 0. Is that true? Because I already know that -4 is a solution. Then I should have a remaining. Remaining polynomial here. All right, let's go with it. So 1 goes down. 1 times -4. 0 plus -4 is -4. -4 times -4 is 16. -28 plus 16.
That is all. No, sorry, that's 12.
12, okay.
Negative 12.
-12, okay. -12 times -4 is a positive 48. Oh, voila, I got it. Done. Okay, so let me just kind of show you where we're at here. So I just figured this out. I just figured out that x cubed minus 28x minus 48 is the same thing as x plus 4 times, that's my divisor, and x squared minus 4x minus 12. Are we good? And there's no remainder. Okay, tell me if that makes sense. Now the question is, can I factor or can I reduce that x squared minus 4x minus 12? Can I bring that down some more? Because with x cubed, we're stuck. Anything above x squared, but with x squared, we learn how to factor things. We can do quadratic formula. We have all these different tools for x squared. But once you go to x cubed, we're like, we don't have any more tools.
That'd be x plus 6 times x minus 2.
I think so. Let's go x. You guys box it if you guys need to here. Do the x box if you need to here. So this is x squared. This is -12. And find me the pieces. And I need a -4x here. Perfecto. That means this is x, that's x. 2x, -6x makes -4x. Perfect. X plus 2x minus 6. Okay. So it says that it'll list for me all the remaining solutions to this equation. So if I set this guy equal to 0, talk to me. Let me do it like this. If I set each of these equal to 0. -2 and 6. There it is. So this x cubed polynomial has zeros of -4, -2, and 6. Just to go a little bit beyond, because we're gonna have to do it later on anyways. So this x cubed polynomial, I know for sure that I have -4, -2, 1, 2, 3, 4, 5, 6. I have those zeros that are happening with it. Again, going a little bit beyond what we're looking at in the textbook here. So I'm thinking this graph goes like this, and eventually kind of something like that-ish. But at least I know my zeros.
Is there a certain amount of x's that it's no longer possible to have something like this where you can split it down?
Perfect. So notice, Noah, good question here. Notice we factor this down into its linear form. There's 3 of them, actually right here. X, X, X.
Right.
Because there's only so many x's here, I've got all of them in linear form. I solve for it, so there's can only be three x's. Okay. So the number of zeros of a polynomial are the same amount as the exponent or less. But you can only have at most 3. It's a pretty good question. You guys talk to me here. Let's see. Let's go off on a slight tangent here. So I have x cubed. X cubed goes like this all the time. That's the look of x cubed. Good. Can you guys draw x cubed? Or I'm going to draw it. I'm going to draw x cubed with 3 solutions, which is going to look like just the one that we just made. Boom. Can you guys draw x cubed with only 2 solutions, which means it crosses the x-axis or touches only in 2 spots? All yours. And then can you graph another one with only 1 solution? So it has to look like that. Here's my 3 solutions. Give me 2 solutions. Give me 1 solution. And give me 0 solutions. So 3, 2, 1, and 0. All right, anybody want to volunteer their 2 solution problem? Or 2 solution graph?
This minus where it only goes to, it only touches on the second down,
I'll let you say it, but then let me, Noah, the other Noah, go ahead, Bobby.
Might be that way because one of the touches on the second curve.
Perfect, yeah, goes up. I think both of you guys said it correctly here. So then right here just touches only and then comes up. So there's 1 and 2 only. Cool. Pick on some other people here. 1 solution only, go. How does that look like? Anybody want to volunteer their graph for the 1 solution?
Could it be the same, but it doesn't touch the X at all on the second graph?
Absolutely. Goes up and then it just goes like this right here. It just crosses once. Cool. All right. Good job. 0 solutions. Say again?
If you don't know the error, you're going to keep the number down and up.
We learned something in 2.1. It says for x cubes, right? They start low and they have to end high, right? For these guys, in behavior, it has to go through 0, right? There's no other way, so not possible here. Perfect, yeah. X to the 4th could. Any odd number would have to have at least 1 0 behind it. Okay, that's cool. We got that. We found the rest of 0. Now that was the easy one. Let's do a little bit more complicated. So B. X cubed plus 2x squared minus 2x minus 4 equals 0. So I'm gonna write that correctly here. And then how about this one? Ooh, how fun, a square root inside there. And that is not even the funnest yet. All right, let's see. First things first, I got to check. Or you know what? Hold on real quick here. Do we have to check? Do we have to plug in the square root of 2? And to see if it makes 0, or when I plug it into my synthetic division, if I get a remainder of 0, I know it's a solution. Right? One of those two. So this one right here, we plug it in to get this guy. We verified the same thing. We verified that and that. That's actually verifying the same thing. Because if you get a remainder of 0, you know it's a factor. But if it's a factor, you know it's a solution as well. So cool, I don't need to do this check anymore. Let's just do synthetic division right away. And if it turns out to be a remainder of 0, then we did great. Okay, square root of 2 on the outside. And the way we begin, let's go. Okay, I need numbers on top.
1, 2, -2.
Perfect. Okay, and then my little box for remainder. Bless you. And bless you. Ooh, this is turning out to be a little fun. And so I drop the 1 down. 1 is 1, and then what's 1 times square root of 2? Square root of 2.
Negative square root of 2.
No, it would be whatever it's equal to.
And this, well, because the positive square root of 2 doesn't subtract anything from 2.
Yeah, so it's just going to be 2 plus root 2. How's that for some fun? All right, what is the square root of 2 times 2 root 2? There's lots of 2's here.
Multiplying the square root of 2 by the square root of 2 cancel each other out. So then it would just.
I think it would just be like multiplying here would be 2 root 2, right?
Yeah.
Then multiplying here, you're saying that's going to cancel.
Yeah.
It's going to make it into a perfect square. Yeah, perfect square of 4. So square root of 4 is back to 2. Okay, this is fun. If we go over here, then we get ourselves an answer of 2 root 2 plus 2. What's the addition after that?
So wouldn't it just be 2 square roots of 2?
Yeah, 2 and -2 cancel off. Is that right? And then you just have this guy only right there. Looks crazy at first, but the math just works out. This is cool. Okay.
This last one was 4.
Hey, all right. So if I do the next one, it's going to be square root of 2 times 2 root 2. Let's see, that's going to be 2 on the outside, square root of 4 on the inside, which becomes just 2, which becomes just 4. It works. Okay, let's jump to here. And we got ourselves the 0. Can you guys write for me the remaining polynomial that's left?
Whoever figured this equation, like way to do the equation, how it's very smart. If we think for the less work.
Yeah, because it'd be more work. If we did it. Could you imagine doing this by Roman numeral stuff? Anybody want to do it that way?
Oh gosh, no, I'm good, thanks.
Okay. Okay, hopefully you guys have something that looks like this now. I have myself a x squared plus, in parentheses, x plus the 2 root 2. Is that what you guys have? Yes. You should if you don't. Okay. Oh man, that's trouble. Okay, now we got to do.
Did we just take out the x to the third?
Did we just take it out? We did this right here. The question is, did we just take out an x to the third? We took out an extra multiplier of x minus root 2. That's what we took out. Because once you multiply it out, then you'll multiply it back in. Okay, guys, now we got to find the answer to these guys. Oh boy. Okay, so now let's do some thinking here. Do you guys remember Pythagorean Theorem?
Yes.
Okay, do you guys remember the Pythagorean Theorem? Once you get to the end, or actually it itself is negative b plus or minus the square root of all the stuff inside here. Are we good? All over 2a. But notice you have a plus and minus. Which means if this was a square root of 2, what's another answer that should be there as well? Oh, I think Landon got it. If you have a positive square root of 2, you're also going to have a negative square root of 2 as well because of the plus and minus. So once you understand that you have a square root of 2,
What is bottom numbers to what?
2a. Yeah, let me rewrite out. Let me write out completely here. Let me do this because it'll be easier to have it like this. It was b squared minus 4ac all over 2a. So if inside there, it seems like our answer is like this. Is that what our answer looks like? There's nothing in front of x squared. And on the bottom, there's no fraction, so it must be 1. So therefore, we were just introduced to the positive square root of 2 as an answer. There's also a negative square root of 2 as an answer. So let's do this again real quick here. How about negative square root of 2? And what are my numbers? They're just crazy now.
Is that equals C? I'm sorry,
There were?
on e squared minus 4 is that?
AC.
Ah.
So 2 plus the square root of 2 and 2 root 2. And my expectation is I'm going to have to get a 0 right here. Hopefully I will. All right, all yours. Try this one with square roots inside it. We're going to do one more with something else.
Why are they doing this with the input from the second equation instead of the first equation?
Because the question is, why are we doing this as an input of already this?
Because we're
Second
trying to find
equation.
another
Second
answer,
equation.
not the, well, if it's another answer, it would plug into this as well. So it,
Could you use the first equation?
The first equation here, yes, you could have used the first equation again. The only thing is, you would have wound up with like 2 minus square root of x, and that would have not helped you
Oh,
because you're not bringing it down further and further.
got it.
Because once we get this done, we should just wind up with a linear function like x minus 3 or x plus 2 or something like that. Good question. So 1 goes here. 1 times the negative square root of 2 makes a negative root 2. All that added together, anybody?
2.
Thank you. 2 times the negative root 2, negative 2 root 2. And did we get our 0? Absolutely. What's the remaining leftovers?
0.
Sorry, yeah, I should have said that here. The remainder is 0. What's the quotient that's left over?
X plus
X plus
2.
2. Awesome, we got it then. Okay, so hold on. So my answers are, the given was the square root of 2. So we don't count that one. The other answers that we got is a negative root 2. And now we got ourselves a negative 2. Are we agreed there? Okay, one more, just one more difficult one beyond this one. Okay, so make sure are we okay there? It just had square roots inside it. Whenever you have square roots, you can do the opposite of it. We call it the conjugate. You guys remember what conjugates are from Algebra 1? No? Let's negation station. That's funny.
I
Okay.
actually read that as well once.
Yeah. The negation station. How funny. Okay, so a square root of 2, the conjugate of that would be a negative square root of 2, which we just learned, right? And so notice what we technically have, if we want to, we could put a 0 plus square root of 2 inside there, right? So That's a conjugate. So all yours here, square root of 7, conjugate is negative square root of 7. Negative square root of 5, positive square root of 5. 3 plus the square root of 5.
Or plus, isn't negative 3 plus?
Fine, here it is. The 3 still is positive, and we just change the sign to the square root on the back end. So the numbered front stays exactly the same. It's just the inside sign that changes for the conjugate. Okay, so let's do one more.
How do you know if it's a conjugate?
A plus B and an A minus B. It's the two terms are exactly the same. The only change is the sign in the middle.
Okay.
Okay, so C. All right, x cubed minus x squared minus 13. You guys stay ahead of me if you like. We good? That's my equation, and this is my answer. I know that 2 minus root 5 is an answer, and give you guys about a 20-second head start. Go for it. All right, let's go. Okay, this is 2 terms now. 2 minus root 5 on the outside. And we're gonna do a little bit of work here. So 1, negative 1, negative 13, negative 3. I'm gonna kind of go all the way out here. 1 comes down. Okay, cool, cool. Multiplying together, 2 minus root 5. Everybody good there? And this is where the trouble began.
This is where the box method.
Oh, negative 1 plus 2.
That is
Just 1. 1 minus root 5.
Oh,
There's that.
No.
This has.
Oh, yeah, I wrote 1 too.
This has.
Oh, wait, no, and then
Ooh, it should be 0.
I have a question.
Yeah, sure. So now we got to multiply that and that.
Do we have to do the box method for this?
You can, yeah. You could do FOIL method or box method to multiply it out. Yeah. Yeah, let's do the box method on the side here. So let's see. That's gonna be 2. That's mean root, let's see, 2, sorry, 2 root 5. This is another negative root 5. And then we get ourselves this guy, negative root 5 times another negative 5 gives us positive 5, because it's negative times a negative. And root 5 times root 5 makes root 25, which just gives you a nice little 5 again.
So then wouldn't that be 7 minus 3 square root 5?
I agree with you on that.
There would be a good answer because that's 6 minus 3 square root 5.
Okay, yeah, so 7 minus 3 root 5.
Then it would be negative 6 minus 3 square root
Negative
5.
6 minus 3 root 5. Oh boy, and let's try this one now on the next slide.
We don't have to even. We can just look at that and realize that a negative 6 and 2, that's gonna already be more than negative 3.
Oof, okay, let's take a look at it then here. That times go back over here, negative 6, negative 3 root 5. Oh boy, let's see if this is gonna negative 12. Whoa, okay, that's big. That's going to give us a negative 6 root 5. Multiplying here gives us a positive 6 root 5. Oh, wow, that's interesting. And then we get ourselves, talk to me, negative root 5 times a negative 3 root 5.
That would be 5 times 3.
Yeah, so then that'll give us with a positive 3, which will cancel out. So we get-
So positive 15 here. These guys are gone. And we get ourselves a 3. Sweet. Okay, let's go back over here. That gives us a 3 and that gives us a 0. Well, we're not done yet. Thought we were. Okay, got my 0. I love it. Okay, now what's the other answer that's going to work here?
-2 plus square root of 5.
Uh-uh.
no, sorry,
2
the
plus
square-
square root 5.
2 plus root
Only
5.
change
Yep.
middle.
Middle term changes only. Perfect. Okay, so let's go here. So I gotta go back and forth here. 1, or you guys give me the numbers here. 2, is it plus root 5 now? Yeah. And my numbers are 1 and
1 minus the square root of
thank you. And the next one, -6 minus 3 root 5, is that right? Yes, okay. And that should be it though, right? Yeah, okay. Okay, so can we do this one? And then this guy, yeah, this guy better be a 0 at the end here or else we did something wrong. Almost there. A lot of math, guys. It is like in the weeds right now. We're just like going in there. Sorry about that. We don't see the overall picture. This is just tediousness of mathematics right here, guys. I want to show you this before you get to your homework. How about that? Is there a benefit there? At least you're like, oh, okay.
You're telling us the homework is first.
No. So the homework is very similar to this one.
Wow,
Oh.
that's so bad. That's a big promise. I still dislike that.
The multiplication is not bad. Good, look at this here. We're gonna drop down the 1. 1 times anything is itself. So you really have this right here to your, right? That's not bad. What comes out of this? That's just a 3. Oh, nice. Okay, so then let's multiply 3 times that.
So it's -6. So 6 squared.
Yeah, it'd be 6 times 2 is, yeah, 3 times 2 is 6. And then, hey, awesome. So what's left? What's the quotient here? Okay, can you guys give me the remaining zeros if I know that x is equal to 2 minus root 5? Yeah, sure. So let me go back to the problem itself. So if I know that 2 minus root 5 is one of the answers, can you guys give me the, oh no, hold on the homework it says list all real solutions. So we list all of them. Okay, so oh, good here. So how about this? I'm gonna list this 2 minus root 5 because that was already given. What's the next one? 2 plus root 5, awesome. And then the last one. And a 3, cool. So that is how we write them. Another way to write it, if you like, is like this: 2 plus or minus root 5. You kind of put those two together as one. There's still 2 different answers. You just write a plus and minus so that you can write them shorter, and then you put a 3. Oh, yeah, something wrong here though. Waiting for someone to see something wrong.
Wait, so isn't it x plus 3?
Oh yeah, hold on.
X is equal to -2.
Yeah.
Good, good, good. So real quick here, this is not x equals 3. This is x plus 3.
So that's a -3, x equals negative.
Did I catch anyone? Yes. Ha, ha, ha. So if you set equal to 0, it becomes x equals -3. Oh shucks, got to put the little negative inside each one of those. Negative there. Negative there. Just trick you on a Monday.
Rude.
Oh, it did trick you. Okay.
Spotted it immediately.
Okay, and one
We're just
more.
waiting for someone else to point it out. Or from Lawrence.
Like that. Okay. Exercise 10 finally in this section here. So now a little bit different here. Find the constant C so that the denominator. We've got some fractions here in our hands. Divide evenly into the numerator. Okay, so boom, we'll finish with this one here. So find the constant c so that the denominator will divide evenly into the numerator. So I think I'll just, we'll just do one. So here it is. Here's my numerator. And here's my denominator. So all yours, think with me how you guys want to do this here. It's x plus 2 on the bottom. So c could be any value whatsoever. Has to be a constant. So I'm trying to figure what would c be if x plus 2 would divide it evenly, or even better yet, if x plus 2 can factor out something on top.
Can't it factor out at least x plus 1?
I don't know.
Because no matter what, wait, no,
For the fact that it's 2x squared.
2x squared. You can't factor stuff out, right? It has to be factorable, right, in it. So if something divides evenly, does that mean that there will be no remainder? I think so. Okay,
but we don't know a c, so can we really do that?
I don't know.
Please go through the problem, through the whole thing, and then get to the part where there's a remainder.
Yeah,
Then
that's
we
how I
know which-
did it.
Then we know which number we need to be able to cancel it out.
Awesome.
basically.
I think that is genius. Let's go for it. Abby, great job. Okay, okay, first of all, is this a linear form?
Yes.
Yes, it's a linear form. Perfecto. Because of that,
Wait, can you go back just a
Yep.
second? And what should we write down for c?
C will be good. Let's see, x plus 2, that's a linear form. What should we use as the outside number for synthetic division? -2 is good. -2 on the outside.
Fill in zeros.
Oh, yes, there you go. Fill in all the zeros. I got x equals, this is the x to the 5th column, x to the 4th column, x to the cubed column, x squared column. And then you got the linear column and then this little c value. All right. All yours to do that. And then let's see, at the end, we should have a 0 here. That should be a 0.
Well, the remainder is c. Is c plus 20, or c minus 26?
I don't know. Let's see, I gotta finish up 2 here. So 1 here, 1 times -2 is -2. And that becomes -2 here. What's the next multiplier gonna give us? 4. 4, that becomes that, -8, -10, -10, right? Yeah, so 20, 21. Perfect. Okay, so we stopped there. We say to ourselves, hey, look, c minus 42 would have to give me a 0.
So 42.
So c would have to be 42. There's only one answer to do that with. Yep. All right. There it is. Done. Are we good? All right, we were kind of in the weeds today, but made it through. And kind of just this whole concept of dividing polynomials, all the different ways we could do it, all the different ways we sort of look at it to make that happen. Okay. We are done for the day.